If you have ever had one of those days where you feel like you are not getting anywhere, here is a comforting and mildly terrifying thought. You are currently riding a planet that has not stopped moving since the moment it existed. Earth does not do standing still. It does not do pause. It does not even do slow down to admire the scenery. It is a cosmic overachiever glued to a perpetual conveyor belt, dragging everything on its surface, including you, through the universe at speeds that would make a race car feel insecure. And the funniest part is that we do not feel any of it. You are being hurled through space faster than any roller coaster could legally go. Yet you can still sip tea without spilling it. That is cosmic engineering at its finest. Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. Imagine Earth as a rock that won a golden ticket to every ride in the galaxy, and whether or not we asked to go along, the universe strapped us in anyway. It is like someone shoved us into the front seat of the wildest interstellar road trip and whispered, "You might want to hold on." Except nobody gave us seatbelts because gravity took that job. The truly unsettling part is that there is no steering wheel, no brake pedal, and absolutely no map. Earth just goes where physics tells it to go, carving a path so complicated that if you tried to draw it, it would look like a toddler attacked a piece of paper with crayons. Most people grow up imagining Earth as something stable, as though it is politely hovering in place while the rest of the universe handles the chaos. But in reality, Earth is more like that one friend who cannot sit still during a movie night. It is rotating, orbiting, drifting, wobbling, weaving, plunging and surfing through gravitational currents that stretch across unimaginable distances. If the cosmos had a Fitbit, Earth would be that one participant who accidentally runs a marathon every single day without meaning to. Yet here we are, living our daily lives unaware that the ground beneath us is actually doing laps around the galaxy. The funny thing is, we are conditioned to think of movement as something you feel. If your car speeds up, you feel the push. If a plane hits turbulence, you feel the bounce. But Earth moves at mind-melting speeds and does it so smoothly you might as well be floating on a cosmic waterbed. If the universe ever held a competition for best shock absorbers, our planet might win purely out of humility. It lets you walk your dog, eat breakfast, complain about emails, and watch sunsets, all while secretly keeping you locked into a multi-layered cosmic dance routine that has been going on for billions of years. What makes this whole thing even stranger is that this non-stop motion is not optional. Earth is not simply wandering because it is bored. Every motion is part of a gravitational choreography that began long before humans existed. Once the universe formed and galaxies assembled themselves into these majestic swirling structures, everything inside them started moving, and none of it was ever meant to stop. The universe is not a place where objects sit still like items on a shelf. It is a place where everything is endlessly pulled, pushed, twisted, twisted and nudged by the invisible threads of gravity. Earth is just one of the countless participants caught in this vast gravitational tug-of-war, doing its best impression of a cosmic traveler with zero control over the itinerary. Think about how oddly comforting this is. Every time you feel like your life is stuck in place, remember that you are physically hurtling through space at unbelievable speeds. You are basically a passenger on a rock that refuses to nap. And while this rock races through the galaxy, it still manages to support oceans, forests, cities, and late-night snack cravings. It is the ultimate multitasker. If Earth were a character in a space sitcom, it would be the exhausted but determined parent trying to carry groceries, answer phone calls, and outrun a galactic tornado at the same time. But this chapter is not just about the comedy of cosmic motion. It is about setting the tone for the journey we are about to take together. Because once you start peeling back the layers of how Earth actually moves through the galaxy, things get wonderfully wild. Each motion is like a chapter in Earth's secret life story, from the gentle twirl of rotation to the grand sweep of galactic drift. By the time we are done unraveling each layer, you will see our planet not as a stationary world, but as an unstoppable traveler, weaving through the cosmic wilderness with style, determination, and a complete disregard for speed limits. So buckle up, not because it will help, but because it feels appropriate. Earth is already moving, and the tour has just begun. If Earth ever auditioned for a talent show, its first act would absolutely be spinning. It has been performing this routine every single day since it formed, and it never once forgot its choreography. The funny thing is, if you asked someone how fast Earth spins, most people would shrug and guess something slow and polite, like a gentle twirl. After all, when you look out your window, trees are not being flung sideways, your house is not peeling away like a sticker, and your cat is not clinging to the floor wondering what sort of cosmic blender it has been tossed into. But Earth is rotating so quickly that if you could stand above the North Pole and watch, you would see the planet completing a full spin before you were done drinking a cup of tea. That is not a casual turn. That is Earth saying, I may be round, but I can move. What makes this even more astonishing is how that speed translates at ground level. Near the equator, where the planet is widest, Earth's surface is racing eastward faster than the fastest jets humans have built. It is moving with the confidence of a planet that never learned the meaning of take it slow. Yet despite this wild speed, you are not pressed flat against your bedroom wall every morning like you are riding the world's least regulated amusement park ride. Instead, everything feels serenely normal. You get up, stretch, maybe forget to water your plants, and all the while, you are effectively perched on a massive rotating sphere, doing its best imitation of a cosmic spin class. This raises the natural question: if Earth is rotating so quickly, why do we not feel any of it? Why are our stomachs not flipping and our hair not permanently swept backward like we are in a wind tunnel? The answer lies in one of the universe's more considerate features: steady, constant motion. Our bodies are exceptionally good at recognizing acceleration and deceleration, those subtle changes in speed that give us that familiar lurch in a car or the slight sensation of lift when an elevator starts moving. But constant, unchanging motion, our bodies simply ignore it. They shrug and say, "This is fine." And so the massive rotational speed of Earth blends into the background of our senses, becoming as invisible as the air we breathe. Earth also spins with an incredible level of smoothness, like a dancer hitting the same move flawlessly for billions of years. There is no sudden jerk, no uneven patch, no surprise pothole in its rotation. It just twirls with the quiet confidence of something that has done this since before the first spark of life appeared. If the planet ever had a rough era in its spinning career, it sorted that out long before humanity arrived. What we inherit is the polished, streamlined version, the cosmic equivalent of a perfectly trained figure skater gliding along an infinite rink. But this rotational speed does more than just spin the planet. It shapes our experience of time, the cycle of daylight and night, something so familiar that we rarely think about it. Is simply Earth spinning into and out of sunlight, like a rotating display in a cosmic department store. Each sunrise is Earth turning to face the star it orbits, and each sunset is Earth turning away again, all with the calm reliability of a planet that does not miss appointments. It is almost funny to realize our entire concept of a day is just Earth choosing how quickly to twirl, like a cosmic metronome keeping the rhythm of life steady. This rotation also gives Earth a slightly flattened shape, a gentle bulging around the equator, as though the planet is wearing a subtle cosmic belt that got a little too tight. It is not dramatic. Earth is not in any danger of becoming a cosmic pancake, but the effect is real. The spinning motion pushes outward slightly, creating that equatorial bulge and giving Earth a bit of character. If Earth had a personality, it might joke, "I am not round, I am gravitationally well-rounded." Speaking of gravity, it is the hero of this entire situation. Gravity keeps everything anchored as Earth spins, preventing the surface from erupting into a massive outward flinging event. It is the quiet, dependable force that holds oceans in place, keeps mountains where they belong, and ensures your morning coffee stays in your mug instead of launching across the room in some bizarre zero-gravity incident. Without gravity's calming presence, Earth's rotation really would feel like a wild carnival ride. But gravity insists on playing chaperone, making sure everything stays orderly. One of the most curious consequences of Earth's spin is something we rarely think about: the sense that the sun and stars are moving across the sky. In reality, we are doing the spinning, not them. But from our perspective, it looks like the entire universe is circling around us every 24 hours, like a cosmic procession put on purely for our entertainment. It is one of the greatest optical illusions in existence, and the funny thing is that humans believed it long before realizing our planet was the one doing the turning. The sky is not orbiting around you. You are spinning beneath it like a tiny passenger on a gigantic rotating sphere that refuses to slow down for dramatic effect. So the next time you feel stuck, bored, or motionless, remember this: You are riding a planet that flips itself around once every day with impeccable precision. You may feel still, but you are anything but. You are a quiet rider on the world's smoothest, fastest spinning platform, and it is doing everything it can to keep your feet on the ground while giving you front row seats to the greatest rotation in the cosmos. If Earth ever participated in a cosmic fitness challenge, its signature move would be running perfect laps around the sun. And the wild part is that it has been doing this yearly marathon long before humans started marking calendars or complaining about Mondays. Earth does not ask for permission, it does not check the weather, and it definitely does not stop for water breaks. Once every year, with the determination of a planet that refuses to skip leg day, Earth completes a full loop around its glowing central star. And although we experience this journey as the familiar change of seasons, the planet itself is basically sprinting along a gigantic racetrack without ever looking winded. To visualize this orbit, imagine Earth as that one friend who signs up for fun runs, marathons, triathlons, and then pretends it was no big deal afterward. "Oh, I just traveled hundreds of millions of miles today," Earth would say, wiping imaginary sweat from its crust. "Honestly, I barely noticed." And the funny thing is, it would not be bragging. The distance Earth travels every year is so enormous that if you tried to walk it, you would still be walking when the sun turned into a red giant billions of years from now. Even a spacecraft would need to write a resignation letter halfway through. This grand orbit is not a perfect circle, but more like an elegant oval, stretched just enough to make things interesting, but not enough to send Earth careening into a cosmic ditch. This slightly elongated shape means that sometimes Earth is a little closer to the Sun, and sometimes a little farther away, like a polite cosmic neighbor who keeps a consistent but flexible social distance. It never gets too close, and it never wanders too far. It stays in that sweet spot where liquid water can exist, life can flourish, and people can endlessly debate whether it is too hot or too cold outside. What really makes this orbital journey feel like a planetary workout routine is the speed. Earth races through space with a velocity that would make even the most advanced spacecraft jealous. It does not tiptoe around the sun, it zooms. If space had speed limits, Earth would be that one vehicle that whizzes by with absolute confidence, daring the cosmic traffic police to chase it. And yet, this blistering pace is completely necessary. If Earth slowed down too much, it would fall inward and have a very unfortunate meeting with the sun's extremely inhospitable surface. If it sped up too much, it would fling itself outward like a rebellious teenager storming out of the house. But at its current speed, it stays locked in a perfect gravitational partnership, a cosmic dance that never misses a step. What we feel on Earth, though, is a gentle, almost poetic version of this orbit. The shifting angle of sunlight as Earth moves along its path gives us the changing seasons, a slow and steady transformation that makes the planet feel alive. As Earth leans slightly on its axis like a casually tilted hat, each region takes turns basking in longer days or longer nights, warming or cooling, blooming or resting. The orbit is the track, The tilt is the performance. Together, they produce the cycle of seasons that shapes ecosystems, migrations, weather patterns, and even our collective mood. If Earth ever wanted to host a workshop, it could call it How to Stay Productive While Traveling Millions of Miles. One of the most charming details of Earth's orbit is how peaceful it feels from the surface. You do not wake up each morning thinking, "Wow, that was another 5 million miles completed overnight." You do not feel the shift, you do not sense the curve, and you do not notice the speed. Earth wears its orbit like a perfectly tailored suit, smooth, silent, and refined. There is no turbulence, no cosmic bumps, no dramatic swerves. It is motion wrapped in comfort, like gliding along a frictionless track carved into space itself. Yet this journey has consequences that ripple across every ecosystem. Plants respond to the lengthening and shortening of days, thriving in the warm months and retreating during the cold. Animals migrate in astonishingly predictable patterns, following the Earth's shifting position in relation to the Sun, as if their internal compasses are synced with the orbital clock. Human cultures built entire traditions around the turning of seasons, marking solstices, equinoxes, harvests, and celebrations with the same rhythm Earth follows in its cosmic route. The orbit is not just a path around a star. It is the silent director of life on this planet. And here is where Earth's laid-back style becomes almost comedic. Despite the enormous complexity of this orbital dance, the planet acts like it is the easiest thing in the universe. It just keeps going year after year like a long-distance runner who forgot how to stop. It never loses balance, never drifts off course, never pauses for dramatic effect. It simply follows the gravitational groove carved by the sun, maintaining an elegant, reliable pace that humans have used to organize everything from agriculture to school schedules. So the next time you think the year is passing too quickly or too slowly, remember that Earth is the ultimate timekeeper, running its endless lap with a grace and confidence no athlete could ever match. We are passengers on a world that never breaks a sweat, even while circling a star in a cosmic marathon that never ends. And the best part? It always brings us back to where we started, ready to begin the next lap with the same calm determination as the last. If you have ever imagined the sun as a giant, fiery lighthouse politely standing still in the middle of the solar system, you may want to sit down for this next part. The sun does not stay put any more than Earth does. In fact, the sun is the cosmic equivalent of that friend who swears they are staying home tonight, and then somehow ends up on a road trip 3 hours later. It looks calm and stable from our point of view, but behind the scenes, it is soaring through the galaxy with the confidence of something that knows it is too massive for anyone to argue with. Every planet, moon, asteroid, speck of dust, and passing comic book villain in our solar system is tied to the sun by gravity, and all of them travel with it as it moves. That means Earth is not gliding around a stationary ruler of light. It is holding on for dear life to a star that is on its own long-haul journey through the Milky Way. Earth orbits the sun, sure, But that orbit is drawn on a moving canvas, which makes the whole experience feel a lot more like hitchhiking than orbiting. The sun is the driver, Earth is a very quiet passenger, and space is the endless highway where nobody agreed to the speed limit. So where exactly is the sun going? Picture the Milky Way as a gigantic spinning pinwheel made of gas, dust, stars, planets, and the occasional questionable choice. Our sun is tucked inside one of the spiral arms, cruising along a circular path that wraps around the center of the galaxy. But this giant circle is anything but leisurely. The sun races around the galactic core at a pace that makes Earth's own orbital speed look like a warm-up jog. If the galaxy had a marathon, the sun would be the one at the front of the pack, not even pretending to slow down so the rest could keep up. Even though the sun is massive beyond belief, overwhelmingly heavier than everything else in the solar system combined, it is still just one of hundreds of billions of stars participating in this grand orbit around the galactic center. Yet it manages the journey with a kind of star-powered swagger. It does not wobble nervously or drift aimlessly. It flies forward with the grace of something born from the very physics that governs the universe. And everything orbiting the sun, including Earth, is carried along like luggage strapped to the roof of a car that never stops moving. From Earth's perspective, none of this is obvious. The sky still appears serene, the sun rises and sets with perfect consistency, and nothing about its daily behavior suggests it is traveling at unimaginable speeds. But appearances can be deceiving, especially when the scale of motion is so gigantic that human senses simply shrug and ignore it. The sun is racing through the galaxy, and we are coming along because gravity does not believe in letting anyone off the bus without paperwork. The funniest part is that Earth is not just hitchhiking, it is hitchhiking with no say in the matter. If Earth had a voice in this arrangement, it might ask the sun, "Where exactly are we going?" And the sun, radiating in all its ancient brilliance, would probably respond, "No idea. Forward, I suppose." The cosmic journey does not come with a destination. It is simply the ongoing consequence of how stars and galaxies formed. The sun was born inside a swirling cloud of gas and dust, inherited a certain amount of motion from its birth environment, and has been following that inherited trajectory ever since, like a star honoring the last wish of the universe. This movement also has a subtle influence on the shape of everything in the solar system. As the sun speeds through space, it drags its magnetic field along with it, creating a wind-swept bubble known as the heliosphere. This bubble acts like a protective shield around the solar system, blocking and deflecting some of the harsh cosmic radiation drifting through interstellar space. If the sun were a ship, the heliosphere would be the hull, slicing its way through the galactic ocean, and Earth, tucked comfortably inside, simply enjoys the ride, unaware that the sun is basically plowing through space like a cosmic icebreaker. One of the more poetic aspects of this journey is how the stars we see at night are not fixed landmarks, but moving companions, each with its own path, speed, and destination. The sun is not weaving through a static field of lights. It is swimming in a sea of fellow travelers, each drifting along under the influence of gravity. Some stars are moving faster, some slower, some toward us, some away from us. The entire galaxy is like a grand migratory flock that never stops flying. And the sun, with Earth tucked beside it, is one bird in that ever-moving sky. What makes all of this even more astonishing is that we have barely scratched the surface of the sun's full trajectory. Its path through the galaxy is not a simple curve. It is layered, twisted, and influenced by everything from passing stars to the gravitational structure of the Milky Way itself. Earth's orbit wraps around the sun, and the sun's orbit wraps around the galaxy, creating a motion that is more complex than any diagram could gracefully capture. But through all that complexity, one thing is absolutely certain: Earth is not the one driving. So here we are, living on a planet that follows the sun like a loyal but clueless hitchhiker, soaring through the galaxy as part of a journey billions of years long. We do not steer, we do not brake, and we definitely do not get to ask, are we there yet? The sun is in charge, and Earth is just enjoying the ride. And honestly, it is the most breathtaking road trip we could ever be on, even if we never realize the scenery is rushing by at unimaginable speeds. If you could look at the Milky Way from above, ignoring the minor inconvenience that doing so would require leaving the galaxy entirely, you would see one of the most beautiful and misleading shapes in the universe. A shimmering pinwheel of stars curled into elegant spiral arms. These arms look calm and sculpted, as if a cosmic artist delicately painted them with steady hands and infinite patience. But that graceful appearance is a trick of distance. Up close, a spiral arm is not gentle at all. It is a bustling, crowded, star-making traffic jam of gas clouds, newborn suns, ancient giants, and the occasional unlucky comet trying to mind its own business. And right now, our entire solar system is sliding along one of these arms like a tiny surfer clinging to the world's longest, brightest wave. We live in what astronomers call the Orion Arm, a minor spiral arm tucked between two larger, flashier neighbors. If the galaxy were a giant celestial amusement park, the Orion Arm would be the comfortable middle lane where the crowds are thinner and the drama is lower. But the views are still spectacular. It is not the biggest arm, not the brightest, not the one showing off with star clusters the size of small kingdoms, but it is home. And like every other spiral arm, it is not a solid structure. You cannot walk on it, you cannot stand on it, and you definitely cannot draw a straight line through it. A spiral arm is more like a glowing traffic pattern created by millions of stars moving together through the gravitational currents of the galaxy. The reason spiral arms form in the first place is surprisingly dramatic. They are not rigid, static features. They are waves, density waves, to be precise, that move through the galaxy the way traffic jams move down a highway. If you have ever driven slowly for no reason, only to eventually realize there was never an accident or construction in sight, you have already experienced a miniature version of how spiral arms behave. Cars get bunched up, slow down, then spread out again. Spiral arms do the same thing, except instead of cars, They use stars and giant clouds of hydrogen gas, and instead of an annoying commute, the process creates stunning ribbons of light that can stretch for tens of thousands of light years. Our solar system is one tiny speck in this vast, flowing structure, drifting along inside the Orion Arm like a surfer who caught a wave so enormous and long-lasting that it would take hundreds of millions of years to ride from crest to trough. This is not the kind of surfing where you worry about falling off. Gravity does not let you bail out of a spiral arm. You are embedded in it, moving with the same slow, majestic flow as everything else around you. The wave moves, the stars move, and the gas moves, each following the gravitational choreography that keeps the entire galaxy swirling. The comparison to surfing becomes even more fitting when you realize how dynamic the environment is. Spiral arms are crowded compared to the rest of the galaxy, not suffocatingly crowded, but lively. Stars are born here in immense nurseries. Glowing clouds collapse into brilliant spheres of plasma, and supernovas blast heavy elements into the surrounding regions like cosmic confetti. Drifting inside a spiral arm means Earth and the Sun are passing through neighborhoods where stars are constantly being made and destroyed. It is not chaotic enough to threaten our safety, but it is beautiful enough to make Earth feel like it lives in the scenic part of town. What makes this journey particularly fascinating is that the Sun does not stay perfectly inside the same part of the arm forever. The galaxy is constantly evolving, and the Sun occasionally drifts closer to denser regions or farther into quieter zones. But at the grand scale, it still moves with the flow of the spiral arm itself. It follows the overall motion like a leaf floating in a slow, luminous river. Earth, of course, follows the Sun, which means our planet is part of a star-powered caravan cruising through a galactic wave pattern that has existed for billions of years. From our point of view on Earth's surface, none of this is visibly obvious. When you step outside at night and look up, the stars do not seem to be participating in any grand surfing adventure. They appear motionless, peaceful, neatly pinned across the sky like tiny lights on a velvet dome. But that is an illusion born from distance. The stars around us are not sitting still. They are all moving, some faster than the Sun, some slower, some cruising alongside us, some drifting away. We notice none of it, because motion on a galactic scale is far too slow and far too smooth for human senses to catch. One of the most poetic truths about living in a spiral arm is that it influences everything we see when we glance at the Milky Way's bright band in the sky. That glowing stripe is the result of looking along the length of our own arm, peering through a packed corridor of stars that stretches unimaginably far. When ancient humans looked up and saw that dense river of light, they were unknowingly looking straight into the structure their planet was surfing through. They had no idea they were gazing along a cosmic wave their world had been riding for ages. So here we are, Earth, the Sun, and every frozen comet, wandering asteroid, and billowing dust cloud around us, all surfing together on the Orion Arm, a wave so vast that no one aboard ever notices it moving. It is the longest, most serene ride imaginable. A cosmic glide through a glowing river of stars, and as long as the galaxy continues its slow spiraling rotation, we will stay right on this wave, drifting forward through the Milky Way with the elegance of a surfer who never falls and never reaches shore. If you have ever tried to picture the Milky Way, you might imagine it as a giant glowing pancake with a dramatic spiral pattern. But the part that usually escapes the imagination is that everything inside that pancake, every star, planet, cloud, and cosmic dust bunny, is on the move. Not just drifting, not just wobbling, but participating in a full-scale, mega-sized orbit around the galactic center. And when I say orbit, I do not mean something cozy and contained, like Earth's one-year trip around the sun. No, a galactic orbit is the cosmic equivalent of signing up for a marathon, a triathlon, and a continental road trip all at once, stretched across hundreds of millions of years with no finish line party at the end. Picture the sun as a long-distance runner who has been jogging non-stop for billions of years. It never stops to rest, never checks its pace, and never once thinks, maybe I should take a different route today. It is locked into a gravitational loop so immense that even light would need thousands of years to cross the distance the sun covers. Earth, faithfully attached to the sun like a very well-trained sidekick, completes this giant journey without ever noticing the miles ticking by. While humans debate whether time is moving too fast or too slow, the sun is quietly progressing along a cosmic track that makes even the grandest human timescale look like a blink. The heart of this orbit, the gravitational anchor of the entire galaxy, is a dense, mysterious region at the center of the Milky Way. It is home to a supermassive black hole and a swirling cluster of stars packed so tightly together that if you stood among them, the night sky would glow like a permanent festival. But the sun keeps a respectful distance from this busy core. It orbits far out in one of the galaxy's less crowded neighborhoods, like someone who loves the city but lives close enough to avoid traffic. The sun's orbit is not a perfect circle. It is more like a soft, cosmic oval, not too stretched, not too lopsided, just comfortably imperfect enough to make celestial mechanics interesting. As the sun travels around the galactic center, it moves at a pace that would make any race organizer panic. Yet, because the distances involved are so absurdly vast, the journey still takes hundreds of millions of years to complete a single circuit. Imagine taking a trip so long that not only you, but the entire human species would evolve several times over before you made it back to your starting point. That is the scale of a galactic orbit. In the time it takes the sun to complete one lap, continents on Earth could shift into entirely different patterns. Mountain ranges could rise and crumble, oceans could open and close, and new species could appear, while others vanish into fossils and legends. And even though the sun is orbiting on this gargantuan path, it is not moving in a smooth, flat circle. Its journey is far more textured and lively. The sun bobs gently above and below the galactic plane in a kind of slow, cosmic dance, weaving through gravitational currents like a surfer following rolling swells. It sometimes drifts closer to denser regions, sometimes out toward quieter stretches, but always along the same looping trajectory. Galactic orbit is not a fixed track carved into space. It is more like a flexible path shaped by gravity, motion, and the distribution of matter. Earth, of course, is along for every moment of this ride. We orbit the sun, and the sun orbits the galaxy, which means our planet's path forms a spiraling corkscrew-like trail through the Milky Way. If you could trace Earth's motion in a perfect drawing, it would look nothing like a loop and everything like the scribble of an artist who drank too much coffee before picking up a pen. It is a layered, woven, spiraling path, rotation upon orbit, that ties Earth into the galaxy's motion like a bead sliding on an invisible thread. What makes all of this even more astonishing is that nothing about the sun's orbit is chaotic. It is governed by the galaxy's gravitational structure, a balance of forces that guide billions of stars into coherent, orderly motion. The sun is not at risk of drifting into the inner galaxy or catapulting outward into deep space. It is held firmly in place by a gravitational combination of visible matter, dark matter, and the overall shape of the galactic disk. Picture a child's toy train stuck perfectly on a magnetic track. It cannot deviate from the path, even though the scenery constantly changes. One of the quietest but most profound consequences of this orbit is that Earth has never, in its entire history, returned to the same place twice. Every moment you spend on this planet, the sun is carrying you into a part of the galaxy that no human, no dinosaur, not even a trilobite has ever visited. Every sunrise happens in a region of space that has never before seen Earth's light. Every night sky is a view from a new coordinate in an ever-changing galactic landscape. Even though life on Earth often feels cyclical, days repeating, seasons returning, years looping, the planet itself is always traveling forward into new cosmic territory. So when you stand on the ground and feel as though Earth is steady and unmoving, remember the truth. You are on a star-gripped passenger world racing around the galaxy on a journey so enormous, so ancient, so endlessly ongoing that your entire life is just a fraction of a single step along the path. The sun and Earth are cosmic travelers tracing a loop so vast that it almost defies human imagination. And they have been running this route long before life learned to crawl, let alone look up and wonder where the journey leads. If you imagine the galaxy as a vast city made of stars, our solar system is that one traveler who never stays in the same neighborhood for long. It is not lost. It is just incapable of standing still. As the sun carries Earth and all the other planets through the Milky Way, it drifts past other stars, brushes along their gravitational suburbs, and occasionally wanders close enough to give them a polite cosmic nod. We are not exactly on speaking terms with these stars, but we definitely stroll through their neighborhoods like an overly friendly tourist who insists on admiring every house, waving at strangers, and unintentionally causing a mild gravitational stir. Our region of the galaxy is sometimes called the solar neighborhood. a kind of stellar suburb dotted with stars of different ages, sizes, and temperaments. Some are blazing giants, some are quiet dwarfs, and some are dimly burning relics. They are scattered across space with a lot more distance between them than any earthly neighborhood would allow, but on a cosmic scale, they are still close enough to exchange faint gravitational greetings. Even though the nearest stars are so far that it takes light years to reach them, gravity does not care about inconvenience. It reaches across space with a subtle persistence, tugging here, nudging there, mixing the motions of stars into a shared cosmic choreography. The sun moves through this stellar district like a traveler making steady progress down a massive, slowly curving boulevard. It passes stars that drift in different directions, some ahead of us, some behind, some above or below our path. The whole region is alive with motion. Thousands of stars, each carrying its own set of planets, debris and cosmic quirks, all gliding through space like a school of fish navigating a dark, silent ocean. And even though the distances between them are immense, gravity makes sure no star is truly isolated. Everything tugs on everything else, even if the tug is so faint, it would take millions of years to notice the effect. Every so often, as the sun continues its long arc around the galaxy, we drift near another star's neighborhood. Near, in astronomical terms, does not mean we might bump into someone's yard decorations. It means maybe a few trillion miles. But by cosmic standards, that counts as casually dropping by. These close passes are rare, spread across millions of years, but when they happen, they can have tiny ripple effects on the outer edges of our solar system. Most of the time, it is just enough to jostle some distant comets in the far-flung reaches of the Oort cloud, an icy sphere of leftover debris that surrounds the solar system like a silent outer shell. A passing star might nudge those comets ever so slightly, as if saying, "Excuse me," while squeezing past in a crowded cosmic hallway. Luckily, the sun is not an aggressive tourist. It does not crash into other stars or veer recklessly toward trouble. It simply passes by at safe distances, minding its own business but still participating in the gravitational interactions that shape the overall motion of the stellar neighborhood. In fact, all stars in this region are involved in this dance, whether they like it or not. It is as though the galaxy hosts a perpetual ballroom, and every star has to hold hands with gravity and learn the steps. Some stars move in similar directions. Others drift off at strange angles. Some speed past us, leaving long trails of motion behind them. And our solar system floats right in the middle of this swirling complexity, weaving its way forward like a friendly wanderer appreciating the local scenery. What makes this gravitational dance so mesmerizing is how slow and quiet it is. On human timescales, the stars seem frozen in place. For thousands of years, the constellations we see at night barely shift at all, even though every star that forms those shapes is actually migrating across the galaxy. If you could watch the sky in fast forward, speeding millions of years into a single minute, the constellations would jitter, stretch, warp, and dissolve like glowing ink swirling in water, stars would drift past each other, some joining new patterns, some splitting away, and Earth would be carried through this shifting panorama as though riding a gondola through a river of fireflies. The sun's path through this environment is not random. It flows through regions where stars have their own clusters and families. Long ago, the sun itself may have been born in such a gathering, a dense nursery of stars emerging from the same giant cloud of gas. Over billions of years, those sibling stars drifted apart, each adopting its own trajectory. Today, long after the sun has left its birthplace behind, it continues its solitary journey through a galaxy full of distant relatives it will never meet again. The stars we pass are strangers from entirely different lineages, fellow travelers who, by sheer coincidence of orbit, share the same space for a fleeting moment in cosmic time. The most charming part of this whole dance is how calm everything feels from Earth. You stand on solid ground, look up at the night sky, and see a peaceful arrangement of stars that seems eternal and unmoving. Yet beyond that quiet illusion, the sun is slipping past stellar neighbors with the politeness of someone squeezing through a crowded room, trying not to bump anyone, but unable to avoid brushing past a few elbows. Our solar system is a traveler with no fixed address, drifting through a galaxy full of strangers and acquaintances, guided only by gravity and momentum. So the next time you glance up at the stars, remember that you are not just looking at distant suns. You are looking at companions, fleeting ones, sharing a moment of cosmic proximity before our solar system drifts onward to the next neighborhood. We are, in every sense, the galaxy's most persistent tourist, always moving, always passing through, always exploring, and never staying long enough for anyone to ask us to pay rent. If the Milky Way were a massive cosmic pancake, and honestly that is not the worst mental image, then our solar system is the little sprinkle that refuses to stay perfectly flat on the griddle. Instead of gliding smoothly along the galaxy's midline, the sun and its planets drift upward, then downward, then upward again in a slow, rolling motion that looks suspiciously like someone bouncing gently on a trampoline. This vertical wobble is not dramatic enough to fling planets into deep space or send stars colliding like marbles in a jar, but it is noticeable when you zoom out far enough. And by zoom out, I mean far beyond anything a human eye could ever witness, without traveling thousands of light years and missing several birthdays in the process. This bobbing motion is what astronomers call vertical oscillation, but you can think of it as the solar system doing a slow-motion dolphin dive through the galaxy. It does not stay fixed above or below the galactic plane. Instead, it crosses that midline, arcs to one side, slows, reverses, passes through again, and repeats the cycle over tens of millions of years. It is an ancient, steady rhythm, like the galaxy breathing in and out, with the sun riding along as if it has front-row tickets to a show no one asked to attend. The reason behind this oscillation has everything to do with gravity, specifically the gravity of the Milky Way's disk. The galaxy is not just made of stars. It is filled with enormous clouds of gas, streaks of dust, clusters of mysterious dark matter and all sorts of gravitational odds and ends. This combined mass forms a kind of flattened gravitational field. When the sun drifts a bit above the galactic plane, that field slowly pulls it back downward. When it dips too far below, the same field nudges it upward again. It is like the galaxy has an invisible rubber band stretched across its middle, gently tugging anything that wanders too far off center. But do not imagine this as a violent yank. It is not a slingshot. It is more like drifting into the deep end of a pool and feeling a subtle current guide you back. The entire cycle takes so long that life on Earth evolves significantly between the high and low points. The solar system has likely completed this rise and fall routine dozens of times since it first formed. Each oscillation slow enough that you could fit entire eras of Earth's history into a single upward drift. Dinosaurs, mammals, oceans, forests, extinctions, civilizations. Every one of them unfolded as the sun continued its timeless up and down sway. You might wonder whether this bobbing has any noticeable effects on Earth. The answer is not directly, and certainly not in a way your daily weather forecast cares about. The motion is too slow, too smooth, too vast. But on cosmic timescales, the solar system's position relative to the galactic plane may subtly influence the number of interstellar clouds it encounters, or the cosmic environment it drifts through. As it rises above the galactic midline, it may pass through slightly different densities of dust or gas than when it dips below. These changes are gentle, not catastrophic, more like shifting from one neighborhood aesthetic to another than entering anything dangerous or unfamiliar. One of the most captivating aspects of this oscillation is the sheer grandeur of its movement. While Earth completes a rotation in a day and an orbit in a year, and the Sun completes its galactic circuit over hundreds of millions of years, this vertical motion takes place on its own majestic schedule, slipping quietly into the background as the solar system continues its epic voyage. If galactic orbit is a marathon around the galaxy's center, then vertical oscillation is the graceful rise and fall of the runner's stride. It is not the main action, but without it, the motion would feel oddly flat and lifeless. From our vantage point on Earth, none of this is directly visible. The galaxy does not flash little indicators saying entering northern zone or descending through midline. The night sky appears steady, familiar, and dependable. Stars rise, stars set, constellations turn overhead, and not a single one hints that the entire solar system is drifting up and down through the galactic disk like a cosmic elevator with a very leisurely schedule. Human senses simply cannot perceive such slow, grand movements. The galaxy does not care about our impatience. It moves at its own tempo, and we are passengers along for the ride. And if this motion had a personality, it would probably be indecisive. It is as though the solar system cannot make up its mind about which side of the galactic plane offers the better view. Let us see what is above, it says over tens of millions of years, then drifting back downward. Actually, the scenery below looks promising. And so the cycle continues endlessly, an eternal back and forth woven into the fabric of our cosmic journey. What makes this vertical dance even more charming is that it reminds us how alive the galaxy truly is. We tend to imagine space as empty, still, and motionless, a cold vacuum where nothing ever changes. In reality, everything is in motion. Stars orbit, drift, wobble, rise, fall, and weave through gravitational landscapes as dynamic as they are ancient. The solar system is not a stationary speck in a quiet void. It is a wandering traveler caught in a grand, spiraling, oscillating pattern stitched together by forces older than time itself. So the next time you look up at the Milky Way, if you are lucky enough to see its glowing ribbons stretching across the night sky, remember this: you are seeing the galaxy from a moving platform, a platform that is rising and falling with cosmic patience. You are standing on Earth, which orbits a sun, which surfs a spiral arm, which circles a galactic center, which bends space-time, all while drifting up and down in a gentle, endless wave. The solar system is not just traveling through the galaxy. It is dancing through it, swaying to a rhythm only gravity can hear. If you thought Earth's motion was dramatic and the sun's journey around the galaxy was impressive, get ready for the next twist in our cosmic road trip. Because the Milky Way, the entire galaxy, with all its billions of stars, solar systems, nebulae, and cosmic leftovers, is not simply spinning in place like a proud celestial pinwheel. No, the Milky Way is being lured, tugged, and gently persuaded across the universe by something far larger and far stranger than anything inside it. This mysterious pull comes from a region called the Great Attractor, a patch of space so gravitationally compelling that entire galactic clusters are gliding toward it like star-filled cities drifting toward a cosmic magnet. To understand this motion, imagine our galaxy as a massive, glowing metropolis floating in the universe. Now imagine that far beyond the horizon, hidden behind clouds of intergalactic dust and clusters of other galaxies, there is a gravitational force so immense it is herding multiple galaxies in the same direction. The Milky Way is one of those drifting giants, being drawn toward this enigmatic region along with thousands of other galaxies, each of them sliding across the cosmic landscape in a coordinated, irresistible migration. The Great Attractor is not a single object like a star or a black hole. It is more like a gravitational hotspot, a place where matter is unusually concentrated, forming a gigantic mass that exerts an immense gravitational influence over vast distances. But there is a twist that makes the whole situation feel like the universe is playing hide and seek. This region lies behind what astronomers call the zone of avoidance, an area of the sky heavily obscured by our own galaxy's dense dust and gas. In other words, the Milky Way is being pulled towards something it cannot even properly see. If galaxies could talk, ours might say, "I do not know what is over there, but I feel strangely compelled to investigate." Despite the obscured view, astronomers have figured out that the Great Attractor sits within a galaxy cluster known as Laniakea, a structure so enormous that it makes our entire Milky Way look like a single street within an endless cosmic city. Our galaxy drifts within this cluster's gravitational domain, the way a leaf floats along a river's current. And as it moves, it carries our sun and earth with it. No seatbelts, no announcements, no chance of opting out. We belong to a galaxy being steadily tugged across space by an unseen gravitational empire. What makes this journey fascinating is how unnoticeable it is to us. While galaxies trek across millions of light years, human lifetimes pass too quickly to observe any obvious change. From Earth, the stars appear fixed, the constellations remain familiar, and nothing hints that our entire galactic home is gliding toward a gravitational feature so massive it bends the motions of galaxy clusters. It is like living inside a ship so enormous and smooth that passengers cannot feel it sailing. The Milky Way is moving, but the motion is spread across such vast distances and slow time frames that human senses simply shrug and walk away. Yet the numbers reveal the true scale of this journey. The Milky Way is rushing toward the region of the Great Attractor at speeds that would make any astronomer pause mid-coffee. Galaxies do not politely stroll across the universe. They glide at hundreds of kilometers per second, driven by the gravitational pull of structures so large we barely have metaphors to describe them. And the thing pulling us is not just a single mass, but part of a larger web of invisible matter and clustered gravity that stretches across the cosmos. Dark matter, mysterious, invisible, and abundant, plays a major role in this gravitational invitation. Think of it as the scaffolding of the universe, creating the framework that galaxies and clusters form around. The Great Attractor region is loaded with this stuff, which means its gravitational pull is powerful, even though most of its mass cannot be seen directly. If normal matter is the furniture in a room, dark matter is the house itself. The Milky Way, along with its neighboring galaxies, is responding to the architecture of this hidden structure, drifting along the cosmic blueprint carved out by gravity long before stars existed. What makes this movement even more poetic is that the Great Attractor is not the final destination. The Milky Way is not falling into some colossal cosmic drain. Instead, the motion is part of a much larger flow, one that continues beyond the Great Attractor toward an even grander region called the Shapley Supercluster. If the Great Attractor is a magnet, then Shapley is an industrial-strength version on the opposite side, tugging galaxies with even more intensity. The universe is not a vacuum of stillness. It is a landscape of gravitational highways, and the Milky Way is cruising along one of them. From Earth's perspective, however, everything feels wonderfully normal. You wake up, go to work, complain about the weather, and eat dinner while your entire galaxy is quietly migrating through cosmic space, not drifting randomly, not wandering aimlessly, but following the gravitational curvature created by the largest structures in the known universe. It is the ultimate long-distance journey, with no beginning we can remember and no end point we can clearly see. So the next time you look at the night sky, remember this: you are sitting inside a galaxy that is not merely spinning, not merely orbiting, not merely wobbling. It is moving as part of a massive cosmic caravan drawn toward a gravitational giant we cannot see directly. The universe is not just expanding, it is pulling, stretching, guiding, and arranging its matter on scales so enormous that the Milky Way becomes just one glowing traveler following the currents of invisible tides. And somewhere out there, far beyond our view, the great attractor continues its quiet pull, gathering galaxies like a cosmic magnet collecting star-filled cities on an endless journey through the universe. If you zoom out far enough from the Milky Way, far beyond the sun's orbit, past the spiral arms, past the halo of ancient stars, past even the region influenced by the great attractor, you will discover that our galaxy is not traveling alone. It is part of a small cosmic clan called the Local Group, a collection of more than 50 galaxies wandering through space together like a family on a very long road trip. And like all family road trips, there is no clear plan, no unified schedule, and definitely no consensus on where they are going. They simply drift, bound by gravity and circumstance, each bringing its own quirks to the journey. At the center of this road-tripping cluster are the two heavyweights, the Milky Way and the Andromeda Galaxy. Think of them as the two older siblings constantly sizing each other up, both convinced they run the family, even though neither fully knows what the other is planning. These two galaxies are by far the largest members of the Local Group, and their mutual gravity acts like the main thread holding this galactic family together. They orbit around a shared center of mass, drawing smaller galaxies along with them as if they are the parents corralling an unruly group of cosmic children. Andromeda, the nearest spiral galaxy to us, is not just drifting alongside the Milky Way. It is slowly, very slowly, moving closer. If galaxies had facial expressions, Andromeda would be giving us the slow motion I'm coming over look from across the intergalactic street. The two galaxies are on a collision course, but the word collision sounds far more dramatic than what will actually happen. Instead of a fiery smash, it will be more like two crowds merging in a large hallway, gradually blending their stars and rearranging their shapes over billions of years. It is not something humans ever need to worry about, unless you plan on being around several billion years from now, in which case you have other concerns. Surrounding these two giants are dozens of dwarf galaxies, each one small, strange, and full of personality. Some are irregular galaxies, shaped like someone crumpled them and smoothed them out halfway. Others are spherical clusters of ancient stars that orbit the Milky Way or Andromeda like loyal attendants. A few drift near the edges of the Local Group, barely clinging to the family gravitational bond, like distant cousins who only show up at reunions for the free snacks. The entire Local Group is spread across millions of light years, yet all its members remain connected by the faint but persistent pull of gravity. What makes the Local Group especially fascinating is that it is not sitting still while all this drifting occurs. The entire cluster is moving across space, influenced by the same cosmic forces that tug at the Milky Way. The gravitational pull of larger structures, the flow of galactic currents, and the overall shape of the cosmic web. picture the local group not as a cluster of galaxies floating in isolation, but as a small caravan moving along a vast invisible network of gravitational pathways. Its members are not holding hands, but they are definitely in the same vehicle, whether they meant to be or not. The motion within the group is just as interesting. The Milky Way pulls on its satellite galaxies, many of which orbited in elongated looping paths. Andromeda does the same with its own entourage. Sometimes a dwarf galaxy drifts too close to one of the giants and gets stretched or shredded by gravitational forces, like a cosmic visitor who got a little too close to the campfire. Other times, galaxies switch allegiances, drifting from one giant to the other over long cosmic timescales. If you watch the local group in fast forward, say over a few billion years, the galaxies swirl, merge, stretch, and drift in a hypnotic celestial waltz that looks nothing at all like the static skies humans perceive. One of the most delightful metaphors for the local group's motion is the family road trip that lacks a clear destination. The Milky Way and Andromeda are the two stubborn drivers arguing over which direction to turn, while the dwarf galaxies are the kids in the back seat asking unrelated questions and wandering mentally. The whole group is moving forward, but not because anyone agreed on a place to go. They are simply following the gravitational contours carved out by the enormous cosmic structures around them. There is no map. There is no plan. There is just motion, steady, ancient, and quietly unstoppable. Despite their aimless wandering, the galaxies in the local group share a kind of gravitational unity. They are bound together more tightly than to anything outside the group. They are part of a larger arrangement known as the local volume, but within that space, the local group is its own separate family. If the universe were a giant neighborhood, our group would be the quirky household at the end of the street, chaotic, busy, slightly unpredictable, but undeniably connected. Perhaps the strangest part of this entire chapter is how unaware we are of it all from Earth. The night sky looks calm, serene, and unchanging, giving no hint that our galaxy is drifting through space beside dozens of others, each following its own ancient trajectory. Yet here we are, living inside a cosmic family that is always moving, always changing, always interacting, no matter how peaceful the universe may seem when we look up. So as the galaxies of the local group continue their slow, unplanned road trip through the cosmos, Earth goes along for the ride without complaint. We are passengers in a vehicle far larger than our imaginations usually allow, drifting through a universe shaped by forces we only recently began to understand. And somewhere in that vastness, the Milky Way hums quietly beside its many companions, part of a journey that no one intended, but everyone is taking together. If the universe had a personality, it would be that one friend who keeps moving farther and farther away during a conversation, not because they dislike you, but because the floor beneath their feet keeps stretching. That is, quite literally, what space is doing. It is expanding, not like a balloon someone is blowing into, but like a vast cosmic fabric that keeps weaving itself larger. Galaxies are not running away from one another. The space between them is simply growing as if the universe woke up one morning and decided it needed a little more elbow room. The result is a slow and steady increase in distance, so subtle in the moment that no one galaxy notices, yet so significant over cosmic time that entire galaxy clusters end up drifting apart like friends who forgot to schedule a reunion. To understand this expansion, imagine the universe not as empty space, but as a flexible grid, like dough rising in an oven. Galaxies sit on top of that dough, quietly minding their own business. As the dough expands, the galaxies move farther apart without actually traveling through space. It is the space itself doing the work, stretching and pulling everything along for the ride. The galaxies are like the raisins in a loaf of bread, except far less delicious and significantly more massive. None of the raisins are moving on their own. They simply get carried to new positions as the bread expands. And just like that, the universe grows, slowly, steadily, relentlessly. What makes this expansion particularly odd is that it does not behave like anything we experience in everyday life. Nothing in our normal world expands uniformly without the help of some visible force. A balloon needs air, bread needs yeast, muscles need regret. But the universe, it expands all by itself, driven by a mysterious ingredient called dark energy. Dark energy is the universe's expansion manager, silent, invisible, and apparently determined to keep stretching space no matter what the galaxies think about it. If matter is the cast of characters in the cosmic play, dark energy is the stage crew, silently pushing the scenery farther apart at every scene change. Inside galaxy clusters, gravity plays the role of the responsible adult, holding galaxies close enough to resist the expansion. But beyond those clusters, the stretching becomes noticeable. Light traveling from distant regions takes longer to reach us because the space between us and the source literally enlarges while the light is still on the road. It is like sending a letter to a friend in a different city, only to find that the city is slowly drifting across the continent as the letter travels. By the time it arrives, the journey has become longer than it was when it started to. The expansion also tells us something profound about the nature of cosmic motion. Not all movement is the result of traveling. Some movement is simply the universe rearranging its own geometry. Galaxies do not need engines or momentum to drift apart. They do so because the cosmic fabric beneath them keeps growing, the way paint on a balloon separates when you inflate it. If you could draw little dots on the surface of the universe, each dot would move away from every other dot, not because they chose to, but because the surface itself is expanding. One of the most intriguing consequences of this is that the farther away a galaxy is, the faster it appears to recede from us. This is not because it is speeding away like a cosmic getaway car, but because the space between us and that distant galaxy is expanding more rapidly. The more space you put between 2 points, the more stretching occurs. It is like placing 2 chairs on opposite ends of a rubber mat. Pull on the mat, and the chairs that begin farther apart accelerate away from each other more quickly than the chairs that start close together. The universe, being the universe, applies this same logic on a scale billions of light years wide. You might wonder whether Earth benefits from this expansion. Could it give us more room to breathe, more space for continents to drift, or at least a convenient excuse for losing your keys? Unfortunately, no. The expansion only happens on gigantic scales. On small scales, solar systems, galaxies, planets, gravity keeps everything locked together so tightly that the stretching of space has virtually no effect. Your house will not drift away, your street will not widen on its own, and your cat will not slowly move across the living room without walking, though cats will always find a way to be strange regardless. Expansion only becomes noticeable when distances grow to astronomical levels. What makes the expansion of the universe so deeply poetic is that it rewrites how we understand the sky itself. When we look at distant galaxies, we are seeing them as they were billions of years ago, their light stretched and reddened by the expanding space it traveled through. Every glimmer from far-off galaxies carries with it a record of how much the universe has stretched since the light began its journey. It is almost as though the cosmos keeps track of its growth in the very wavelengths of its light, like tree rings etched into beams of ancient starlight. And here is the twist that turns all of this from fascinating to mind-bending. The universe's expansion is accelerating. It is not slowing down with age, it is speeding up. That means the fabric of space is stretching faster now than it did billions of years ago. If the universe were a person, it would be the opposite of tired. It would be picking up the pace, expanding harder, faster, and more enthusiastically than ever. Galaxies that were once neighbors are becoming unreachable. Future astronomers millions or billions of years from now will see far fewer galaxies than we do today, not because those galaxies vanished, but because space expanded so much that their light can no longer reach us. So here we are, living in a universe that keeps stretching, pulling everything apart like galaxies that forgot to exchange phone numbers after the last cosmic gathering. We drift, not because we choose to, but because the very structure of reality insists on growing. And somewhere in that expansion, Earth continues its quiet journey, carried forward on a cosmic tide, part of a universe that refuses to sit still. If you could somehow trace Earth's true path through the universe, not just its daily spin, not just its yearly orbit, not just the sun's motion, or the galaxy's drift, or the cosmic expansion, but all of it stacked together, you would end up with a pattern so chaotic, so layered, so absolutely bewildering that any attempt to describe it as a path would feel like cosmic comedy. Earth does not glide through space in a neat circle, or even a graceful spiral. Instead, its trajectory is a swirling, spiraling, jittering, twisting thread of motion woven into layers upon layers of other motions, each one pulling or pushing us in its own grand direction. If Earth's path were a drawing, it would look like the universe handed a toddler a crayon and said, "Go nuts." The simplest layer, and perhaps the least surprising, is the daily spin of Earth itself. You can imagine this rotation as a tiny twirl at the center of everything else, a miniature loop traced once every 24 hours, like a little flourish on a much larger signature. Then add Earth's yearly orbit around the sun, a sweeping circuit that drags that spinning motion along in a looping path. Combined, they already create something more interesting than a simple circle, a corkscrew shape, spiraling through space as the sun pulls Earth forward along its own much larger journey. But this is only the first step, because as Earth spirals around the sun itself is not resting. It is moving along its own trajectory through the Milky Way, with enough determination to make an Olympic runner look lazy. That means Earth's corkscrew shape is being stretched forward, turned, tugged, and pulled along a much grander arc. Suddenly, the neat spiral becomes a long, flowing helix, like a spring being dragged across a table. And the sun's motion is not a straight line either. It is curving around the core of the galaxy in a massive, multi-million-year orbit. So the helix becomes a looping, spiraling ribbon wrapped around a gigantic galactic pathway. Then intrude the subtle motions layered on top of that. The sun bobbing up and down through the galactic disk, the solar system weaving through stellar neighborhoods, galaxies drifting within the local group, and the local group itself being pulled toward massive gravitational structures. Every layer bends Earth's trajectory in some new direction, each motion shaping the next, like a cosmic stack of nested dollhouses, each one holding a smaller but equally restless version inside. The result is a path that defies simple geometry. If you tried to model it, the picture would resemble the flight path of a bee that had way too much coffee, attempted interpretive dance, and then decided to relocate to another continent mid-performance. Earth's motion is not graceful. It is not repetitive. It is not something you could draw in a single clean line. It is a roiling, swirling, forever evolving thread that twists with such complexity that a mathematician might stare at it and say, "Okay, but why?" What makes this complexity even more intriguing is that none of the individual motions cancel out or simplify into something tidy. They all compound. Earth's rotation continues regardless of its orbit. Its orbit continues regardless of the sun's galactic motion. The sun's galactic motion continues regardless of the local group drifting across cosmic structures. Motion upon motion, each layered on the next, each contributing its own flourish to the grand trajectory. If the universe were a composer, Earth's path would be the sheet music, notes stacked, crossed, tangled, and blended in ways that only make sense when viewed as a whole. Imagine standing in the middle of a gigantic three-dimensional diagram showing Earth's motion over the last few million years. You would see loops inside loops, spirals inside spirals, arcs inside arcs, each representing a different rhythm of motion. The daily spin would look like tight curls wound around the yearly orbit. The yearly orbit, dragged forward by the sun's galactic journey, would look like a stretched, elongated coil. That coil would itself be bending along the sun's long arc around the galactic center. That arc would undulate as the solar system rose and dipped through the galactic plane, and the entire bundle would be drifting toward distant cosmic structures like a ball of yarn rolling across an endless table. In fact, Earth's path almost never overlaps itself. Each point along that tangled thread represents a location no version of Earth has ever been before. This makes the trajectory even stranger. It is not just tangled, it is endlessly new. Every second of your life is spent in a region of space that no human being, no dinosaur, no ancient fish crawling onto land, no early microbe drifting in primordial oceans has ever passed through. The universe ensures that Earth's journey is always forward, never looping back, always wandering into uncharted territory. Yet from Earth's surface, none of this complexity is apparent. The ground feels steady, the stars appear still. You walk through your day without any sensation that you are being twisted, carried, dragged, and swung through a cosmic obstacle course. But this quiet ignorance is part of the wonder. Earth hides the chaos with elegance. The motions are so smooth, so gradual, so spread across such enormous timescales that we feel as though we are standing on a stable world instead of a bronze medalist in an intergalactic gymnastics routine. If you could take a pencil and draw your own location in the universe across every moment of your life, you would create a miniature version of Earth's grand cosmic scribble. But Earth's full path, its true unraveling journey through the universe, is a masterpiece of motion, a three-dimensional tapestry woven from gravity, momentum, and cosmic structure. It is a route with no beginning and no end, no repetition, no symmetry, just motion layered on motion, all combining to send our little planet dancing through the universe in a pattern beautiful enough to make chaos itself jealous. If you have ever watched detectives on television solve impossible cases using a single thread of evidence, you already have a sense of what astronomers do. Only their clues are billions of years old, scattered across the universe, and traveling at the speed of light. Scientists do not get to chase galaxies with radar guns or ask the sun to hold still for a moment of questioning. They rely on the only witnesses available, light itself, faint relic whispers from the early universe, and physics so clever it would make Sherlock Holmes raise an eyebrow. Astronomers are, in many ways, cosmic detectives, except their magnifying glass is a telescope, and their crime scene is everything that has ever existed. One of the primary tools these space sleuths use is the Doppler effect, a phenomenon so useful it might as well come with its own badge and detective hat. You have experienced it on Earth any time an ambulance rushes past. The pitch changes as the vehicle approaches and recedes. Light behaves in the same way. When an object in space moves toward us, its light stretches into shorter wavelengths. When it moves away, the wavelengths lengthen. Astronomers call this redshift and blueshift, and it allows them to decipher whether galaxies are approaching, receding, or minding their business at cosmic cruising speeds. Each spectral line is a confession, each shift a clue, each pattern a signature that reveals motion invisible to human senses. But redshift is only the opening act of the universe's detective story. To measure Earth's movement through the cosmos on far larger scales, scientists turn to an even more ancient witness, the cosmic microwave background radiation, a faint glow left over from the earliest moments of the universe. This relic light fills space like a whisper frozen in time, the afterglow of a universe that was once hot, dense and noisier than a stadium full of cheering particles. It is the oldest thing we can see, and it surrounds us in every direction like a perfectly even fog, except for one tiny clue. When scientists study this background glow, they notice a subtle temperature difference depending on which direction they look. One side of the sky appears slightly warmer, the other slightly cooler. This pattern, known as a dipole anisotropy, is not because the universe forgot to iron its background radiation evenly. It is because Earth, the Sun, and the entire Milky Way are moving through this ancient light, creating a temperature pattern similar to the breeze you feel sticking your hand out of a moving car window. The cosmic background becomes the ultimate reference frame, the universe's way of saying, yes, you are definitely in motion. Just by reading this tiny temperature mismatch, scientists can determine not only the speed of our movement through space, but also the direction, like discovering a cosmic breadcrumb trail laid down 13 billion years ago. This method tells us about our galaxy's motion relative to the universe as a whole, something no ordinary telescope pointed at planets or stars could ever reveal. It is forensic cosmology at its finest, looking at the embers of creation and deducing how fast we are flying through the universe right this second. But the detective work does not stop there. Astronomers also use the absorption and emission lines of light from stars and galaxies to map their drift across the galaxy. Every star leaves behind a spectral barcode in its light, thin dark or bright lines that correspond to the elements inside it. When these lines shift, bend, or distort, they betray the star's motion. By collecting thousands of these barcodes, scientists can map how stars swirl, cluster, and migrate within our region of the Milky Way. It is a bit like tracking the movement of every car in a city by looking at the sound of their engines, except the cars are stars and their engines are nuclear furnaces billions of miles away. Even more remarkably, scientists use gravitational interactions to infer motion. When a star shifts slightly back and forth because of the gravitational pull of something nearby, another star, a planet, or even a cluster of unseen mass, astronomers can detect those wobbles. These wobbles reveal how stars influence each other as the solar system navigates its neighborhood. It is like watching the ripples in a pond and working backward to figure out which fish just swam by. On the largest scales, astronomers use galaxy surveys, gigantic maps created from millions of observed galaxies, to chart how cosmic structures shift and drift. Each galaxy's redshift paints part of the picture. Each cluster's distribution fills in more details. Slowly, painstakingly, the map reveals the cosmic scaffolding that directs the motion of galaxies and clusters. Scientists become cartographers of the universe, drawing maps of places no traveler could ever visit, charting routes shaped only by gravity and time. One of the cleverest tools in their kit is something called standard candles, objects whose brightness is predictable and consistent. By knowing how bright an object should appear and comparing it to how bright it does appear, astronomers can determine its distance. Once distance and direction are known, motion follows naturally. It is cosmic triangulation, like using landmarks to figure out where you are on a road. except the landmarks are exploding stars and ancient clusters glittering millions of light years away. What makes all this detective work so astonishing is that it pieces together Earth's full, tangled motion without ever seeing that motion directly. Humans cannot feel the galaxy drifting. We cannot watch our solar system glide through star fields. We cannot observe the expansion of space unfolding around us. Yet through light, tiny shifts, and background radiation older than time itself, scientists assemble the clues into a coherent narrative of motion so grand and complex that it feels almost fictional. But it is real. Every wavelength of light is a message. Every shift is a clue. Every faint hiss of cosmic background radiation is a testimony from the dawn of time. And through these whispers and signals, astronomers become detectives, unraveling the story of how Earth moves, not just around the sun, but through the galaxy, through cosmic structures, and through the very fabric of expanding space. In the end, scientists do not need rocket chases or interstellar pursuit squads. All they need is light, physics, and the patience to listen to what the universe is quietly telling them. If someone ever tells you that your life is not going anywhere, feel free to gently remind them that you are currently rocketing through the universe at speeds that would make even science fiction spaceships hesitate. You may be sitting at a desk, walking your dog, or staring into your refrigerator wondering why you keep opening it when you already know what is inside. But you are also part of an astonishing cosmic voyage that never slows down, never loops back, and never repeats a single moment in the same place. You are a passenger on a world that never stops traveling, swept along currents of motion older than human memory, older than Earth itself, older than the stars that paved the way for our existence. It is almost funny how quiet the universe makes this journey feel. On Earth, motion is obvious only when you zap across town in a car, or launch in a plane, or trip over your own feet. But the motions that truly define our existence, Earth spinning, orbiting, spiraling, drifting, rising, falling, and surfing through gravitational fields, happen in silence. There is no hum, no vibration, no dramatic soundtrack. The universe is polite about monumental things. It does not draw attention to its grandest motions. It lets you go about your day while it carries you through an ever-changing cosmic landscape, like a chauffeur with a perfect driving record. That quietness, though, can make us forget what we are part of. We often think of ourselves as small, stationary beings, living stable lives on stable ground. But the ground itself is anything but still. It is part of a layered cascade of movement so intricate it makes any human invention look like a scribble in the corner of a masterpiece. Earth is spinning faster than the fastest roller coaster. Earth is orbiting a star racing through a galaxy. The galaxy is drifting through a web of cosmic structures shaped by forces we have only recently learned to measure. And all of this happens while space itself stretches and expands around us, rearranging the distances between galaxies, like a cosmic stage crew changing sets between acts. When you think about all that, the idea of being stuck anywhere becomes almost poetic. You cannot truly be stuck while traveling thousands of miles every minute. You cannot be unchanging while the planet beneath you is twisting a path through the cosmos more complex than anything ever drawn by the human hand. Every moment of your life is spent in a region of space the Earth has never visited before and will never return to. Even the atoms in your body were once drifting inside stars, drifting inside galaxies, drifting inside the early universe itself. Motion is not just something that happens to us, it is part of who we are. And there is something beautifully grounding about realizing that. Our worries, stresses, and anxieties often feel enormous, heavy enough to weigh us down. The universe, on the other hand, quietly nudges us forward at breathtaking speeds, whether we feel ready to move or not. It is a reminder that motion is not always something we choose. Sometimes it is simply the nature of existence. The universe does not ask whether Earth wants to orbit, or whether the sun wants to circle the galaxy, or whether galaxies prefer drifting apart. Motion is the rule, not the exception. Yet within that rule, there is space, literal and metaphorical, for meaning. We exist on a small world with oceans, forests, deserts, storms, and sunsets, all unfolding, while Earth participates in a cosmic dance too vast to see. Our entire history happened during this movement. Every story we tell, every discovery we make, every moment humans have ever shared took place while Earth traced its tangled path through the universe. We build civilizations on a migrating planet. We fall in love on a traveling world. We learn, hope, grow, and dream while drifting through a cosmos larger than imagination. In a strange way, the relentless motion also connects us. It means everyone who has ever lived, past, present, or future, rides the same cosmic wave. We are all passengers on Earth's impossible voyage. No one gets off early, and no one is left behind. When you look up at the night sky and see stars that seem perfectly still, remember that those stars are moving too, following their own grand trajectories. Everything is traveling. Everything is changing. Everything is part of this shared cosmic journey. And maybe that is the quiet message the universe offers us, that motion is not a sign of chaos, but a sign of life. That drifting forward is part of what it means to exist. That even when you feel like nothing is shifting, everything is shifting. The universe does not allow stillness, not for galaxies, not for stars, not for planets, and not for us. So as this story draws to a close, take a moment to appreciate the invisible journey carrying you onward. You may never feel the speed, but you are racing through the galaxy with a grace your senses cannot capture and a purpose the universe does not need to explain. You are part of something immense, ancient, and astonishing. A cosmic odyssey wrapped in the quiet illusion of stillness. And even if life sometimes stalls or slows, or feels like it is circling the same concerns, remember this truth. You are never truly standing still. You are always moving forward, carried by a universe that refuses to stop, on a planet that keeps going, on a journey that has never once paused since the dawn of time.